Identify the balanced skeleton equation for the combustion reaction. According to the data table, the combustion of 1 mole of the unknown compound in the presence of oxygen gas is represented by the following chemical equation. Unknown plus 5O2 gives 4CO2 plus 4H2O. Count the total number of atoms of each element on the product. Right side. Carbon, C. There are 4 moles of Cu2, which equals 4 times 1 is equal to 4 carbon atoms. Hydrogen, H. There are 4 moles of H2O, which equals 4 times 2 is equal to 8 hydrogen atoms. Oxygen, O. Oxygen is present in both products. 4 moles of Cu2 contribute 4 times 2 is equal to 8 oxygen atoms, and 4 moles of H2O contribute 4 times 1 is equal to 4 oxygen atoms, yielding a total of 8 plus 4 is equal to 12 oxygen atoms. Apply the law of conservation of mass. The law of conservation of mass dictates that atoms are neither created nor destroyed during a chemical reaction. Therefore, the reactant, left, side of the equation must contain exactly the same number of carbon, hydrogen, and oxygen atoms as the product side, for C, 8H, and 12O. Account for the atoms contributed by the known reactant, O2. The reactant side contains 5 moles of diatomic oxygen gas, 5O2, which supplies 5 times 2, is equal to 10 oxygen atoms to the reactants. Deduct the known reactant atoms to solve for the unknown formula. Subtract the atoms provided by 5O2 from the total atoms required on the reactant side. Carbon atoms needed. For minus 0 is equal to 4 carbon atoms hydrogen atoms needed. 8 minus 0 is equal to 8 hydrogen atoms oxygen atoms needed. 12 total needed. 10 from O2 equals 2 oxygen atoms. Determine the molecular formula. Because 1 mole of the unknown compound must contain exactly 4 carbon atoms, 8 hydrogen atoms, and 2 oxygen atoms, its molecular formula is C4H8O. 2. This matches option D. The correct answer is option D, C4H8O2.